Hello. Hello. Welcome to our weekly comparative economics webinar. We are delighted to have Professor Benoit with us today. Before briefly introducing him, let me just mention the house rules. We're going to be running his presentation. If you have any clarification questions or any questions in general, please use the Q&A facility at the bottom of your screen. Just type them, type your questions, and we will stop at 20 and 40 minutes during the talk to collect the questions, etc. And then the last 15, 20 minutes, we'll have a more traditional Q&A session in which you raise your hands and we will mute you and you can ask your questions. Okay, well, let me just briefly introduce Ken. Ken, is a huge pleasure for us to have you here today. Ken is a professor of computational social science at the Department of Methodology at the London School of Economics. And today we'll be talking about measuring textual sophistication in specific domains using machine learning. The floor is yours, Ken. Thank you very much.
Thank you very much for that introduction, and I'm glad that I can take part in this. Given the nature of Zoom, I'm not sure how many people are taking part, but hope it's a lot, and I hope I hear questions from you towards the end of the talk. So today's topic comes from an intersection of data science and political science. This is about an application that I developed to solve a specific problem in political science, but I'm going to try to phrase it in a slightly more general way because the application, the method that we devised to solve our problem can really be adapted to measure actually not just textual sophistication in a specific domain, in another domain, that not just political language, that could be economic language or legal language or medical language. You could actually adapt this to scale anything that has no definable metric, but is something that people would be able to judge using pairwise comparisons. So there we go. So this is joint work, by the way, with Kevin Munger and Arthur Sperling. Kevin is at Penn State now, but he's formerly at NYU, and Arthur Sperling is at New York University. This is the puzzle that motivated our study. This is a this is a plot from The Guardian that was published some time ago now, but we saw a lot of this around 2016 when a strange reality TV candidate presented himself as a candidate for the US election. Also, he won that election. But people started analyzing the sophistication or the reading level of the text based on speeches. These plots here represent the size of the speech, and the different colors distinguish the presidents. And you can see it's a timeline, but the overwhelming thing that you notice from this plot is there's a declining trend. So the sophistication of the text delivered as State of the Union addresses over time has been declining on a measure known as Flesch-Kincaid. Flesch-Kincaid is an index that consists of a regression type index of the average sentence length and the average word length. And the one thing you notice is that there's nothing special about particular presidents towards the 2000s, 2010s. And in fact, if you looked at George W. Bush, Obama, and Donald Trump, they're indistinguishable on this metric. But if you were to look at someone like James Monroe, who delivered a speech back, this is actually James Adams here, the all-time prize winner for the most difficult State of the Union address, you would need about 26 years of formal education according to this metric, which would mean 2 PhDs, something like that, to understand what the hell he was talking about. You saw articles like this, you probably see some more. This was during the election campaign. Donald Trump talks like a third grader. Well, according to the Trump-Kincaid index, it's supposed to be calibrated to the number of years of formal education in the US system that are required in order to understand the text. So they run through the language and it comes up with an index. Now, just to show you what this is like, here are two snippets of text, one from James Adams delivered in 1791 and one from Donald Trump in 2015. This is a single sentence here from James Adams, and it scored a 19.3 on the Flesch-Kincaid index. So do the math. 12 years of formal education takes you through high school, 4 years in the US for university. That takes you up to 16, another 4 or 5 for a PhD. That's basically you need to be all ABD, as they say in the US, or almost finished with your PhD in order to understand this text, maybe. And then there's this word husbandman. So I won't read it out, but the abundance with which another year is again rewarded the industry of the husbandman is too important to escape recollection. What is a husbandman? Well, it's a term that people don't use anymore, but in 1791, it was fairly common. It meant a small farmer. Donald Trump in 2015, we've got to build a fence. It's got to be a beauty. I build, it's what I do. I build great buildings. Fences are easy. Believe me. This sounds a little bit like, you may have heard of this, maybe not. You ever heard of Dr. Seuss, the Cat in the Hat? He doesn't have a PhD, I don't think, Dr. Seuss, but I'll read it anyway. So I get a kick out of reading Dr. Seuss at academic talks. I know some good games we could play, said the cat. I know some new tricks, said the cat in the hat. A lot of good tricks, I will show them to you. Your mother will not mind at all if I do. So these are really short sentences with really short words. Those are the things that determine the reading difficulty, and in this case, 0.7. So you basically could understand this if you were 2/3 of the way through your first year of school. You would need to be nearly finished to understand Donald Trump in 2015 with your first year of school. So let me tell you everything in a nutshell. And this is good for you economists, because I know you like to jump in with questions after 15 minutes. So I'm going to tell you everything, and then the rest will just be clarification. So what do we do? Well, we wanted to come up with a measure of the textual difficulty or the textual complexity, we also call it textual sophistication, that is developed for political speech. Why? Because something that might measure Dr. Seuss doesn't necessarily measure the speech that is used in modern politics. And we had this problem of it being a different domain. So how do we do this? We chopped up our text into short fragments, 1 or 2 sentence, what we call snippets. We then took pairs of these snippets and we compared them to figure out which one was easier. We called this reading ease. In other words, which one of these two, A versus B, was easier. We then used an ordinal comparison scaling method to estimate as a latent variable the underlying easiness without having to actually define that. We then used a machine learning method to figure out, of all the textual features that might be predictive of this underlying estimate of difficulty or easiness, actually, which ones were predictive. And then we used this to form our own metrics, our own measure, essentially, in the form of a predictive model. We fit another model, this time with the covariates that survived the cut from the machine learning part in the 4th bullet point. And then this method could then be applied to text that we didn't have the measure for, but we could measure on the input variables, and then we could estimate its difficulty relative to other texts. We tried to take uncertainty seriously, so we wanted a probabilistic method that would allow us to come up with confidence intervals, because the whole point of social science is comparison. You can't compare two things if you don't have some probability framework for telling us whether one is greater than the other or one is different from the other. And then we wanted to apply this to a large political corpus or large political corpora to track variation in sophistication across time and across speakers. So that's basically what we did. So let me give you the details. Now it's all just details. So here's one detail. This is what the classic measure looked like. We call this Flesch reading ease. Flesch reading ease essentially is a regression equation. And this was developed based on textual markers that are easily and objectively, well, almost objectively measured. So the number of words divided by the number of the sentences is the average length of a sentence in words. The number of syllables divided by the number of words is the average length of a word in terms of its syllables. You then fit this to some measures where you're asking school kids to read certain texts. These school kids have a known educational level. Then you can come up with some score, you calibrate this, and Flesch was calibrated so that 100 was sort of a value at which your sort of a typical educational level person would be able to understand the text. Higher numbers in this case meant easier texts, unlike what I showed you, the rescaled method of Flesch-Kincaid. But there's just two inputs here. How long are the sentences? How long are the words? And these coefficients come from a regression that was fit by Flesch. Now, the key things to realize that this is from a very different domain from our problem, because our problem is designed to come up with a way to redo this measure that is appropriate to our domain. So we designed this for educational research. Sorry, the original measure was not designed for political text. It was designed for educational research. It was tested not on adults who are voting and making political decisions, but on school children. And this creates what we call an out-of-domain prediction problem. It's a problem where our model doesn't necessarily apply, or at the very least is untested, and therefore might not be producing things that make sense. And this is one possible explanation for this declining trend where apparently we're all getting dumber, or at least we're being communicated to as if we were dumber. This was also developed, this original paper, which has a lot of sites, by the way, a lot. I wish I had that many sites. 1948, Flesch wrote this in 1948. Now, 1948, that's a long time ago. This was the same year that transistor radio was invented and that the vinyl long playing record was created. So we consider this a relic of a bygone age. So what did we do? In a modern way, we needed human annotators. Now, if we were Google, we could make people do one of these things instead of a CAPTCHA where you have to identify where the traffic lights are, but we can't do that. So we had to pay people through a crowdsourcing platform. We used something that at the time was called Crowdflower. You could use Mechanical Turk. You could use your favorite crowdsourcing platform, or you get an army of students to do this, but we used crowdsourcing. And the job basically did the following. So just to show you what it looks like, I'll skip ahead and then I'll go back. The job was this. We said, here's text A, here's text B. We did some Coarsen matching to come up with roughly comparable pieces of text, but we made people say A is easier or B is easier. There was no possibility of a tie. We did some early testing where we allowed ties and too many people chose the tie, so we disallowed it. And the job is to read these both and say which text is easier to read and understand. So we fed through this process every possible 1 and 2 sentence snippet from the State of the Union corpus. Now there are 240 of these speeches because they've been delivered every year. It's a constitutional requirement that the President of the United States delivers this to Congress. We disregarded some of those that were too extreme. We used some coarsened matching on length so that these two things wouldn't be radically different, but different enough that people could make a meaningful comparison. You do the combinatorics and pretty soon you've got a very large possible set of pairs. So we created 10,000 pairwise comparisons between snippets that we randomly chose, 2,000 randomly chosen snippets. And we got these coded 3 times each. So for our production data that we fit our model to, we had a total of 6,000 data points. This was the job that the tasks of the workers had. And then we used this information. So we had all the information about these snippets. And we also had an indication from our 6,000 codes of whether people thought A was easier or B was easier. And then we used this to fit our first stage model. A first stage model was something called an unstructured Bradley-Terry model. This allows us to generate a rank ordering of the text and to come up with this score lambda, which in the Bradley-Terry literature is equivalent to an ability score. So the original application was different teams in a league might not necessarily play all of each other, but as long as they're in some minimally connected network where you can perform a transitive ordering through commuting or whatever the commutation principle that, you know, A may not have played C, but A played B and B played C, and we can use that information to scale them because they're connected. And we made sure that our snippets were minimally connected. So we started with all of the constituent variables of any model of readability that had ever been devised. And since Flesch's original paper in 1948 up and through the 90s, there have been all these different people who came up with different ideas for improving the mousetrap, but they're all essentially these static models where they would do this in a particular domain and say, okay, here's the new index. It's better than all of the other indexes. But they had a lot of features in common. We added two things that no other previous measure had. One of them was part of speech variables. We used Spacey, which is a Python-based part of speech tagging NLP system, to tag the part of speech variables, as well as the depth of the dependency clauses, the textual level of sophistication that, well, I should say that the level of subordinate clauses in each sentence. We also took the Google Book corpus, which has a frequency distribution of every word used in the Google Books that has a specific year attached to it. This allowed us, within the context of the year that the word was used, to look up its relative usage in that year. And to smooth this out, we did this to the nearest decade. So you might not hear anyone using the word husbandry in 2020, but you could hear a lot of people using it in 1820. And we were able to get a benchmark of how rare this was in those terms using this measure. We then used random forests to select the variables. Once we had our unstructured estimates of lambda for each text, we then computed all these different variables, and we used random forest to figure out which inputs were the most predictive in explaining variation on that. This is a bit like putting them all into, I don't know, Love Island, and then we just keep letting the regression vote people off the island until we're left with a core group of predictors that we want to include in the next stage. So this basically involved a next stage where we fit not an unstructured Bradley-Terry model, but a structured Bradley-Terry model where we can include our covariate matrix X, and we can estimate a vector beta equal to the number of variables that we retained from this selection process. Just to show you what we put through the system, and also to organize it, this is from the paper that was published, we've got a group of basically things such as the length of words, the rarity of words, the length of sentence, and the complexity of the sentences. And these had to do with, we looked at all the different variations from all the different, over here, these are all the different people who've come up with measures. Like every person who did a PhD in, I don't know, corpus linguistics would try to do a better job of coming up with one of these measures. And we tried all of the components that anyone had ever tried. And that's what we threw as the 29 candidates before getting booted off of the variable Love Island. I'm not sure that's the best metaphor, but we ended up with 4. So this led us to come up with, essentially, it was actually sort of 6, and we pared some of them down. For example, the mean word syllables actually was replaced with the mean word characters, which turned out to be much easier to compute than the syllables, because for syllables, you have to look them up in a syllable dictionary, and depending on the pronunciation and the accent of the speaker, the same word may have different syllables. Syllables are not determinate, and it requires a special handling for every language, whereas this could actually be computed irrespective of language. And this is just to show you some different performance that we got on the different models. One thing to note, so if you go back to the Flesch reading ease measure, the original measure, it didn't do too badly, actually, in predicting snippets in the way that we tried to predict whether people thought it was easier or more difficult. So here we go from 0.6568 to 0.587. That's not an absolutely enormous gain, which goes to show you that sometimes you can apply a lot of high technology and you realize that the old school measure didn't get it that wrong. Maybe that's the reason why it's still around. But I'm going to show you that there are significant advantages to our approach that have to do with the method and also the structure of the model. So here's one of the advantages. This is a method that is explicitly built for comparing things. And as social scientists, this is what we're interested in. We're not really interested in an abstract sentence that, you know, Donald Trump speaks like a third grader. We're interested in something that might say, let's compare the speech made this year to the speech made last year, or let's compare the labor speech to the conservative speech, or party A to party B. Let's come up with something that's really built for these comparisons. And that's what this allows. So with these 4 inputs, and these would be the values. So these are the values for a speech by George, I think, Herbert Walker Bush and Dwight Eisenhower. And if we take these 2 speeches, or these are actually sentences in the paper, just snippets of text, and we compute their values on these 4 dimensions, then we can put that X matrix into the fitted model and then come up with a prediction of lambda. And this prediction of lambda is an explicitly comparative framework where I can compute the probability that text I is easier than J using this simple formula. And this would tell me that, for example, the probability that Eisenhower is easier than Bush. And it turns out that when you plug these in this simple way, you come up with a probability of 0.425, which tells me that it's unlikely, relatively, that Eisenhower is easier than Bush. So Bush seems to be easier than Eisenhower. And this is not something that you can do explicitly with any of the static indexes that came before. So our application of this would also allow us, of course.
Ken?
Do I hear a question?
Yes, Ken, sorry. We have one question that I think it fits well at this moment. Elliot Ash asks you, how do you deal with using present-day evaluators if you want to measure changes over long time periods? Older period snippets could be harder to read, not because of sophistication, but because of unfamiliar / outdated language.
Very good point. So we do include this measure of word rarity. And this was predictive. So interestingly, the proportion of nouns and the word rarity were not present in any previous measure, yet they survived the Hunger Games, the variable Hunger Games for the final cut in competition with all of these classic measures. So however, the ratings that on which we were scaling the original lambdas, it's true, were coders that I think most of the coding was done in 2017, 2018. They would have no idea what husbandry meant. But if you remember the task was, which of these 2 snippets do you think is more difficult? Now it's true, if a key component was a word that they didn't understand, they might think that that's more difficult. But one of the so if that's the case, then we're a little bit wrong. There's not much we could do about it. You would not need to necessarily, so maybe the proof of concept of going back in time to 1791 was not the smartest thing to do to prove that this works, because you wouldn't have that problem if you were just dealing with something a little bit more contemporaneous. That's true. And if you didn't understand a word like, I don't know, take a hard word, supercilious, right? You ask your average millennial who doesn't read, what does that mean? They're not going to know what that means necessarily, right? So that could be just as hard for them as husbandry. And sorry if I've offended anyone. That's a relatively uncommon word. So this measure actually works well to capture that. And we think that's one of the reasons it's working, not because of rare words used in 1791 and not today, but just if you look at how often certain big words are used and some presidents use them, then that is also highly correlated with how difficult the rest of the text would be. It's not isolated. But you're right, if you were trying to pick this up using contemporaneous coders, it's probably not the best application. Do I have a solution for that? Not really. But I think that if anything, it's probably leading to weaker estimates of these factors than you would have if that weren't a problem. And another thing that, this is usually a question people ask that I'll anticipate by answering it now. One of the questions people like to ask is, well, what do we know about these coders? Like, who are these coders? How qualified are they? Do they have college educations, or, you know, did they drop out of high school, or are they people with PhDs who can't find a job? Like, who signs up to do these jobs? And the nice thing about this framework is, in a way, it doesn't matter. They have to all share one characteristic, which is that they pass the qualification test by answering questions that we know the answer to, and we make them get, I think, 70% correctness on. And we monitor a certain threshold of continuing accuracy throughout the course of the job. But we don't care what their level of education is, because they're not necessarily needing to understand text A or understand text B. They have to look at the two and say, I don't know what that means, but I think that A looks harder than B. And that's the nice thing, is that irrespective of your level of education, someone who has high school education is probably going to recognize the harder bit, just like the PhD person will recognize the harder bit. It's a sort of thing where you don't need to be able to define it. You just have to be able to know it when you see it. And that's why I think this could have application for many constructs. Like, let's say you're trying to measure deception. You're trying to figure out whether someone is being deceptive. That's a really hard thing to do with machine learning, sarcasm and deception. But if you ask a human, they can get a pretty good sense of which one is more deceptive than another without, but they would find it really hard to tell you possibly why. If you got the features of those through this sort of process, and then you were able to use this relative scaling to then try to predict that, you wouldn't need to measure it directly. You measure it indirectly through these comparisons. Okay, so what did we do? Well, we did some rescaling, but to show you one of the applications, like, why is this a good measure for social science? Well, it turns out that there were 7 speeches. So one of the things I should tell you is that in the middle of the 20th century, the president started to fulfill their constitutional obligation to deliver the State of the Union report. Previously, a lot of them had delivered it in written form. And this is one of the biggest reasons why the language became simpler. And it's also because people would watch it live. They would listen to it first on radio and later watch it on television. And when you deliver a speech on television, you sound a bit like a jerk if you read out a sentence as long as what James Adams said. I think you probably sound like a jerk if you write that too. But people, when they speak today, they use simpler sentences. Shorter, not simpler necessarily, but shorter sentences, not long sentences. And to the extent that that's one of the major components of the classic indexes, shorter sentences cause everything to look simpler. And in fact, they're not simpler, or they are simpler, but in a good way. So this shift was not complete. Even up to 1980, there were some presidents that, for whatever reason, were delivering their speech both in written and in spoken form. On the same day, they would deliver a spoken version of what they delivered in written form. And we assumed that there was no real difference in the content, just a slight difference in the delivery. And then we could use our measure to compare the probability that the spoken text was simpler, was easier than the written text. And we come up with probability estimates that are around 0.6 and very even across the range. People say, where's the bar on Carter in 1978? Well, this was an extremely short text. And the method we used to compute uncertainty basically didn't show variation that indicated a bar. So what's the measure of uncertainty? This is a very good question. Do we have some kind of analytical estimate? No. Do we have, I don't know, sampling from a posterior distribution? No. What we do have is non-parametric bootstrapping from the original data. This is a method I've used now in several projects, which comes from the simple idea that if I deliver a speech of 100 sentences, the message would be slightly different if I were asked to repeat it. And I know because I gave a version of this talk to Facebook last week, and I'm giving you the same talk, but if you were to compare my words, they wouldn't, everything I say was pretty much the same content, but the actual words would be highly correlated, but not identical. So if you were to make me do this again tomorrow, I would probably deliver more or less the same thing I'm saying, but if you you could get an approximation of that by taking my original transcript, parsing up the sentences, and drawing new transcripts by sampling with replacement from the sentences. And this is how I think textual bootstrapping should be done. You can do that, and then you can predict, you can use that to predict, you compute these 4 inputs, and then you predict a new value. You do that 100 times, your range of empirical replicates for that exercise produce this 95% confidence interval. That's how we got the bootstrapping. Such a simple idea with text, but even though I've used this in a couple of publications now, it's not quite caught on the way that I thought it would. Okay, so that brings me to my conclusions. So first is our model is better than all the previous models. What a surprising conclusion. But we know that this works in a political context. So we can at least be confident that this is true in the context that we wanted. The things that we had distrust of at the beginning, which was, can we take a measure from 1948 out of the context of time and out of the context of the original domain, which was, I think, educational psychology or learning disabilities, and apply that to contemporary political speech? We're more confident that our model is fit appropriately to that context than we are of the previous measures. And we're also a little bit comforted that the previous measure, the king of the previous measures, we have the 2 input variables are still part of our model in a slightly more mechanical form. The interesting thing for this context, so if you're not a political scientist, and I gather this group is largely not, and you've got some other domain, the workflow is really interesting. Because if you can come up with pairwise comparisons for something that people know when they see, but can't explicitly define, you could use something like this to replicate the workflow to come up with indexes for other measures fit to your context. And we claim in the paper that this would work for other domains of text, but you could go even more broadly than that and come up with non-measures of sophistication, something like deception, for example, or anger. All of the code, if you want to try this, there's an R package I've written called Sophistication. It's on my GitHub account, and I've got a link as the last slide. So we basically put this into a package in R. This is also built on top of my R package called Quantita, which just won an award, by the way, for the best statistical software in political science. I'm happy to say, finally won an award. All this, that's where the readability statistics are calculated. So we spent a lot of time getting the readability computations correct. The additional machinery to create the pairwise comparisons, to do the tagging, to calculate rarity, it includes the data that I've compiled from the Google Book Corpus, which is a pretty big data set. It includes our fitted model. So if you want to use the fitted model from the published paper, you can take one function and generate a measure of difficulty for any new text. It's just a predict method for any new text. It also can do the bootstrapping that's necessary to produce intervals. And if you wanted to use this to extend for some non-textual measure, it would be there too. This is just a snippet of the, this is a reference to the package and an indication of some of the corpora that we have included. And I will say, finally, then I'm done, we published a book chapter in a book at Cambridge University Press book that came out last year as well, that answers the substantive question is basically, are we getting dumber? Like, should we be concerned? And we concluded we're not. There's something unique about the State of the Union address that has to do with the change in the mode of delivery, and also the, basically this particular speech seems to be getting simpler, but other things don't. So the political party broadcast from the UK, they don't seem to be getting simpler. Legislative speech is not getting simpler. Electoral executive orders are actually getting more complex, not less complex. Only the State of the Union showed this trend. So if you are worried that this is in some way meaning that we're all becoming simpletons, you shouldn't be worried, because it's a trend that's unique to the State of the Union. I'm happy to take questions.
Amazing. Thank you very much, Ken. Indeed, we have a couple of questions. So first, 2 questions from Elliot Ash. The first question is, do presidential history scholars give the same rankings as the crowdflower annotators? Do you have estimates on this?
That's an interesting one. I doubt it, because if you were to look at, so I think the presidential history scholars would probably give some assessment overall of the president without focusing on their particular speech. But I don't know. I'm not that much in with the presidential scholars. But my guess is probably not. Interesting question.
Okay. Then we have another question by Elliot Ash. Maybe it's better if I mute you for this one, if you agree. Elliot, now you can unmute yourself.
Can you hear me?
Yes, we can hear you.
I can. Nice
Hi,
work.
Elliot.
So I just wanted to say that, I guess for the first question about the presidential history scholars, I was thinking rather actually making the text-wise, the pairwise comparisons. If you ask them to compare, you know, an Eisenhower sentence to a Bush sentence, and you like told them the year, and you asked them which is more readable, and they would try to use their expert historical context about experience about this, what would they say? And then the second question is, which is related to this, I think, is like, you know, because you mentioned earlier about you might want to try to apply this to economics language or legal or medicine language. It feels like, I'm just thinking from my perspective, from legal language, you could have these words like, you know, beyond a reasonable doubt, which would seem very unreadable to a layperson, like the crowdflower annotators, but for a lawyer, it would seem really simple.
Yeah, I don't know if they find some of their own language simple. So this goes back to the second thing I'll take first. I mean, that kind of goes back to the question about whether your absolute level of understanding influences your ability to indicate which is simpler or which is not. And you'd think that a lawyer looking at two complicated pieces of text would still be able to say which one is slightly simpler than the other. And also you'd think that anyone would have, you know, anyone, whether they're a lawyer or whether they basically have a fifth grade education, would be able to look at a piece of legal text and Dr. Seuss and say Dr. Seuss is simpler. What we were more concerned with was actually that this comparison, the ability to make this comparison wouldn't necessarily be smooth or linear throughout the range. And I suspect that there are boundaries where it's much harder to tell, like, you know, a 9 from a 10 versus a 9 from a 2. One of the things that we did when I didn't go into details because of time, but when we did this course in matching for pairs, we didn't allow James Adams to be compared to Bill Clinton. There's just too much time in between. We set a maximum limit on the number of years. I think it was 50 years maximum between presidents. And
that's important. That's a good idea.
Yeah, because, you know, we didn't want things that were radically different because of the language. And not just the language. Some of these sentences include reference to historical events that people wouldn't have a clue as to what they're talking about. We filtered a lot of sentences that were not eligible. Like there are a lot of, it used to be in the written ones, there'd be a lot of references to numbers. Like they would just basically put their budget into prose, which no one does anymore. And then going back to the first question, which had to do with whether you could put some, I think you were asking if you put some substantive knowledge in along with it, would that improve comparison? Is that like knowing the year?
Yeah, that's the idea.
We deliberately did not supply that information because we wanted to come up with a measure that didn't require any of that information. And in other words, we wanted it to come from the textual features entirely. We also felt we could be introducing bias, especially with contemporary presidents. You know, if you're comparing, well, hey, it's fair game. Trump has compared himself to Lincoln. Let's take Lincoln's language and compare that to Trump's language. If you put the label of the president, you know, people who had formed a prior opinion that whatever Trump says must be really, really simple and dumb are going to come up with that opinion and apply that to the text. They're going to be colored by that. And in previous work I've done where we've asked annotators to to rate text or to identify the party, the direction of a political orientation in a text, we found that if you gave the party label, then it did introduce a shift in how people without the party label would have assessed the text. Knowing a piece of text comes from, for example, Nigel Farage's party, UKIP, caused people to assume that it was more anti-immigrant than it actually was.
Thanks.
Okay, great. So we have one other question by Robin L. Cady. He is asking, I was wondering whether there is any way that the algorithm takes into account the difficulty of ideas expressed in writing. Some ideas might be extremely difficult to understand conceptually, but they are expressed with easy words, making them easily readable.
Let's see. Can you repeat that one more time?
Yes, sure. I was wondering whether there is any way that the algorithm takes into account the difficulty of ideas expressed in writing. So, yeah.
Right. So we tried to stick to things that we could measure almost mechanically or simply. And one of those things that that required was that we could apply a measure that didn't require us to form a qualitative judgment about the idea complexity. And the way that we did this was we would use this dependency parser that looked at all the clauses and the depth of the subordinate clauses, and therefore the number of different ideas that might be expressed in the text, including nuance. And we assumed that greater depth was a more complicated way of expressing ideas. Now, that's obviously not going to capture everything. So we were asking people to read the two texts. And yes, when it was a more complex expression of ideas, people would find it harder. But other than that, we didn't really have much of a measure. So there are limits to our approach to what it can do, but the advantage is that it's really easy to measure. So how could we get around this? Well, we actually tried a few things that we abandoned along the way. And one of those was a comprehension test. In fact, this is what the original measures of reading complexity did. They would ask people to take a test of answering a few factual questions after reading the original text. And you would see I think the original definition of flesh was that I think you had to answer 80% of the reading comprehension questions right, and for it to be considered, that you successfully understood it. Did we try that? No, because then you do have to compare. You do have to know something about the educational level of the people involved. And in crowdsourcing, that means you would have to ask them, and then you would have to gather that information, and then you're into a whole nother ethical realm. You also have to verify whether they're telling the truth. And if we didn't use crowd people, then we could use students, but we know that the students we had access to at NYU and the LSE, they're highly advanced, super smart people that we wouldn't have much variation on. So we just decided not to go there, but that's a good idea.
Okay. And then there is another question by Tim Schleicher. And the question is, did you think about researching the visual and spoken delivery of the speech in terms of complexity? That would be cool, of course, only for those where video and audio material exists.
There's some really interesting cutting edge work being done in political science by people who are looking at audio and video. And there's a guy named Dean Knox, I think he's at MIT now. There's a guy named Bryce Dietrich, who did some work at Harvard last year. I know because I think I accepted both of their papers for the American Political Science Review when I was editor there. I was editor until a week and a half ago, one of the editors there. And I was just really fascinating stuff where they look at audio levels, where they have the time of the transcript pegged to the actual text, and they can compare the text with audio levels and look at volume and pitch and what that signified. They can also, the stuff that Dean is doing looks at basically video and does a lot of classification of people based on the recording of their video. Now, what would that mean in terms of the complexity of a speech? Well, it's an interesting question. What sort of hand gestures do people make? All these speeches were basically delivered behind a podium. maybe the most recent president would make gestures that kind of look like that or that, you know, wax on, wax off, that sort of favorite gesture, Trump gestures. Do those signify anything? Maybe those are markers for when they start to say a certain thing for emphasis, but I don't know if that would really translate into, in this case, complexity. I kind of doubt it, because these speeches are written before they get up to gesture. So the gestures might be their interpretation of, as they go along with their own transcript, but they're really delivered as part of the act, not as part of the communication of something that might be new.
Okay, great. There is one other question by Roland Friedrich. Roland, I allow you to talk. Now you can unmute yourself, then we can hear you.
Okay, so my question is, as I wrote, how genuine are these texts? I mean, over the last decades, I mean, you have an increasing number of staff who is just constructing speeches in order to construct them like an ad or make them more catchy. So I think I doubt that these speeches truly reflect the educational level of the president. So I think it's constructed and geared towards a televised audience. So you make them simple in order that the phrases stick with you.
I completely agree. And that's one of the conclusions we drew, that as you increase the size of the audience and as you moved towards the radio and then the television medium, you saw that the way that the message was packaged was delivered in a simpler and simpler form. The content wouldn't necessarily be different. If you read these speeches, even the old ones, the scope of the issues that they covered is still very broad, and they would still talk about their agendas, their plans, and some retrospective assessment of how they'd done in the previous year. That's remains true, but I think you're absolutely right that you know, the question is, what does it say about the president? Well, we never pretend. If we had to pretend in politics that what politicians say is truthful and sincere, we wouldn't really get very far. But what we say is that this is what they have strategically chosen to say in this context, and the rules of this context are the same for every president, which is why we chose a formal affair. If we were to choose speeches that were just happened to be made here, there, and everywhere, we would not have the same control of the context, because it's going to depend, you know, whether you're speaking to a webcam in your basement, or whether you're in front of a White House helicopter, or whether you're giving a rally in North Carolina or something like that. This gives them a certain equivalence, because they're all delivered for a certain purpose. And then we don't really need to get into the head of the president. We just need to say, let's compare what was said as part of a constitutional exercise of this Communication Act, and we can compare them on that basis.
Okay.
Okay. Great. Thank you, Ken. If you have any further questions, please raise your hand and I can then allow you to speak for the Q&A part. I actually have a question myself to you, Ken. One big advantage of NLP exercises is always that it is language blind, right? And I'm wondering, can you apply the methodology that you have used also to other countries, to other languages? And are they then, because it's a comparative webinar series, are they comparable to each other? Or is this very difficult to scale across languages?
Language blind is going a little bit far, but you could apply our same methodology, because you could measure, you know, you would need a historical benchmark of frequency for the words in that language. So let's say we were doing this in German, we would need a historical usage record in German. And, you know, contemporary usage is actually really easy. A lot of people would just take the Wikipedia corpus and use the proportion of words from that and assume that that's more or less, you know, covers everything, which it doesn't, but it's pretty good. We needed historical measures. That's why I used the Google one. The part of speech tagger would need to be trained on that language. That's easy to find in German. We can get the Spacey models have German models. I think at least 2 German models. What else? counting the number of characters and the number of words and all that sort of thing is good. There is one feature of German that's a little bit different. You know, you compound words where you take like what would normally be a paragraph in English and just make one monster word in German. But that should still survive. That the handling that, you know, would either work with that or take that into account. So I think it should work in German. I think it should work in other languages, assuming you can get the coders to do that in other languages.
Yeah. Then we have one hand by Robin L. Cady. Robin, I allow you to talk now.
Yes, can you hear me, everybody?
Yes, we can hear you.
Perfect. Professor Benoit, first, thank you for this amazing talk. I'm a huge fan of your work and your R packages in particular. So
I'll send you a laptop sticker if you want.
Yes, amazing thing. So I was just wondering, maybe in order to circumvent the problem of certain PR strategies that are meant to purposefully make the text very readable, I was wondering whether your algorithm could also be applied to texts that are not meant to be public, maybe thinking about international treaties, legislative text to an extent maybe. So basically analyzing whether these texts have become less complex over time, maybe then making a stronger case that the world is getting dumber, or God knows.
That's an interesting question. So it should, there's nothing to, you know, the status of being secret won't affect whether this works or not. But maybe part of your question was, you know, would this be a way? So an interesting thing, this, in a way, that what we did provides it's an anonymization of the text. So if you wanted to do this for, you know, the secret love letters of Bill Clinton that you couldn't make public or whatever, or, you know, or some kind of thing that you downloaded from WikiLeaks that you wanted to analyze, but you get in trouble if you let people know, or I don't know. If you were to parse this up into individual sentences as we did and strip all the identifying information, then, you know, as long as it's not a sentence that's obviously saying, you know, the nuclear code is, you know, 1, 2, 3, 4, ABC, as long as it's not something like that, you're in essence taking these things out of context enough that you're anonymizing the text, but you can still perform this comparison. And this actually gets to a weakness. So if there's one weakness, if I were to identify one weakness that fortunately no reviewer thought of our approach, is what we're doing is we're fitting this model to really short text, and then we're computing this for a much bigger text. And I'm not sure that the parameter estimates actually scale that well. So, you know, we're taking 2 sentences based on these 4 measures, and then we're measuring these same attributes across all the sentences in a bigger text. And we're assuming that it just applies. But that's an untested assumption. And I mean, we did test it. We didn't find massive differences, but there were some things that, you know, it wasn't always the same depending on how long the text became. There were a few effects there. So, you know, this aggregation is something that gives you a type of secrecy, really, because the people who are performing the analysis, it's a bit like if you go to one of the most common crowdsourcing tasks is image recognition and audio transcripts. So you might be given 5 seconds of audio and you're supposed to type what it said. The system that you have for aggregating that crowdsourcing puts it in order and then puts the transcriptions in order, and then basically you get your audio transcribed by asking people to only worry about five minutes of it, or doing the same thing for, say, OCR of text. And it preserves the anonymity because no one could piece the entire conversation together. I don't know if that is what you were getting at in your question, but it's an interesting thing to think about.
Thank you.
Great. Are there any further questions or any more hands? Not so far, I think. Oh, we have one more, do we? Robin, we can still hear you. Do you have another
perfect.
question?
I mean, I would love to ask another question if that's all right. So I was just wondering whether there is any example, whether there are some instances where political texts and speeches have actually become more complex and harder to read, which would be yeah, an interesting example maybe that manifests the like a counterwave against the whole social media readability.
Executive orders in our study have become more complicated. And I'm going to actually paste in the reference to that in response to your question in the chat. That was one of the things where we wanted to see, we tried to find some other texts that were recorded over time for the same people to find out whether, okay, you know, the president does not write the executive order, his legal team drafts it, but it is, they do include some non-legal components, right? They're designed to communicate something that can be implemented and followed. I don't know if that's necessarily the best example, but we also found that it was essentially slightly increasing for the Supreme Court decisions. And for other texts like legislative speech, it was pretty much unchanged.
Okay.
So there are some domains, but you know, they tend to be more technical. Why? Because law is more complicated today. And we also think that we also think that the nature of what executive orders have to deal with is also possibly more complex. So here's the reference.
Thank you. And it's a good way to obscure illegal problematic statements for sure, maybe making them more complex.
Yeah, a lot of executive orders can be challenged in the court though if they're unclear, or they can be ineffective if they're not clear. And some of the early Trump administration's rules about immigration had that problem, for example.
Thank you.
All right. I think we will officially close the seminar. I'd like to thank Ken very much indeed for a truly fascinating talk. I must say, we invited other political scientists, but they didn't pick the bait. And we hope we're going to use this next term. So, well, Ken gave the talk, why don't you? But it was absolutely fascinating. I enjoyed it very much. Mixing the State of the Union, Hunger Games, Love Island, and Dr. Seuss, and all the technical apparatus. It was really fascinating. We should have more of this. Then what we usually do is thank you so much. I mean, indeed, it was a great talk. We will, Michael, if you can stop recording now, and we officially close